High temperature UT thickness. Does the velocity really change 1% for every 55 degrees? Let's find out. I've got a high temperature probe from Ionix. I've got my Sonotest Wave with the T-log function activated, and I've got a plate that we're going to put on the barbecue. I'm going to use this Ionix HS582i transducer. It's a high temperature transducer. It's got a springy part on the front, nice long handle on the back to keep your hands away from the hot stuff. You can use it for temperatures up to 350 C without cooling, or all the way to 550 C if you follow the duty cycle chart. Now, those temperatures are not going to be an issue for us today, at least when we get started, because what I did last night in order to try and maximize the effect of what we're going to do is I took a 3/8 inch piece of steel, which is 9.5 millimeters, and I put it in the freezer. We'll check the temperature of the plate to start. What we get is about -19 Celsius. Using half-wave rectified signal, echo to echo on the first peak, we get 0.367. I'll store that on the data logger, and we'll go out to the barbecue. I've left the steel outside now for about an hour, hour and a half. It's up to ambient temperature. Ambient today is about 24 Celsius, and now the thickness is 0.368 inches. Steel's been on the barbecue now for about 10 minutes. It's getting nice and hot. We'll use some high temperature couplant. This is Echo Ultrasonics High Tempco. It's important to put this on the end of the probe first and not on the part. It just keeps your hands away from the hot stuff. The temperature of the piece now is about 130 degrees Celsius, and the thickness reading is 0.373 inches. 200 degrees Celsius, 0.376 inches. 255 degrees Celsius, 0.378 inches. And finally, 300 degrees Celsius and 0.381 inches. Now let's make a graph of how the thickness changed with the temperature. Now the first thing you see here is the echo to echo readings, my yellow line, the ones we just did. They line up pretty close with the theoretical. It's maybe not quite 1% for every 55 degrees, but it's close. Now, a couple days ago, I did the same test, but I did it on the first back wall. So it was the peak of the first peak on the signal, but just using the first back wall, no echo to echo involved. And you can see how completely out of line it is. It completely overestimates the thickness of the steel. Remember, the steel is a 0.375 inch plate, and by the time it got to 300 Celsius, I was reading 0.408, which is a big increase. It's far too much. And the reason for that is that the probe tip heats up and it messes with the length of that delay line. And when you use first echo, it will include that. When you use echo to echo, it takes that out. Lessons learned. Number 1, use echo to echo when you're doing high temperature thickness readings. Number 2, this one comes from a friend of mine, David Hermanutz, who's a UT level 3 in Vancouver, BC. Use the nominal velocity and then add the 1% for every 55 degrees, or use the temperature compensation option on your thickness gauge. Do not try to calibrate on a heated cal block. You can. The thing is that it will be very inconsistent between groups of people, and when you're doing CMLs or TMLs, whatever you call them, it's really important to maintain a good trend. If you try to calibrate on a hot block and you do it one way and the other person does it another way, what's going to happen is that chart over time, as they're trending the thickness of that location, is going to be all over the place. And it also won't heat the cal block up to the process side of the material. It will only heat it to the outside because you're on the outside taking readings, aren't you? Number 3, as temperature goes up, so does attenuation, and you're going to have to compensate by adding gain. So increasing temperature means increasing gain. And number 4, try to put the couplant on the tip of the probe. If you put it on the part, it works both ways. The thing is, you just get your hand really close to that really hot spot. And besides, that's why these probes have nice long handles. I hope you enjoyed the video. If you did, please hit the like and subscribe buttons, and thanks for watching.